Hi, this is Christina, inviting you to come and join me.
Welcome to the Deep Dive, where we try to understand why things happen the way they do. So, we've all been there, haven't we? You're interacting with AI, you ask it something, maybe something quite specific, and it just comes back with this answer that sounds absolutely perfect, really confident. You read it, you think, great, got it. Maybe you trust it, and then perhaps you go to double check just in case, and bam, it hits you. The answer is completely, utterly wrong, like not even close sometimes. That feeling, right? That sort of disorienting frustration, that little crack in your trust with the tech, that, my friends, is what people call an AI hallucination. And honestly, for the longest time, it's been one of the most stubborn, perplexing problems with these large language models. So today, we're doing a deep dive. We're digging into some really fascinating new research from OpenAI. They put out a paper called Why Language Models Hallucinate, and we're also pulling in some really helpful insights from analyses. What's super exciting here is that they think they've not only found the root cause, which is kind of surprising, almost counterintuitive, of why these AIs basically make stuff up, but they've also sketched out a remarkably clear path, like an actionable way to actually fix them. So our mission, yours and mine, in this deep dive, is to really unpack why these powerful AIs do this, why they make stuff up so often, and why the reason, once you hear it, feels almost obvious in retrospect, like, oh, of course. And crucially, what this all means for the future. Can we get AI that's actually reliable, trustworthy? Get ready for, I think, some genuine aha moments, stuff that might really change how you think about AI intelligence, its limits, and yeah, its potential. Okay, let's unpack this.
Yeah, and it's really important we start by defining what we actually mean by an AI hallucination.
Right.
Because it's not just any old mistake. As the OpenAI paper and the analyses point out, these are specifically plausible but false statements generated by language models.
Okay.
The key word there is plausible. They sound right, they're convincing, grammatically correct, often detailed, but they're just not based on fact. You could call them overconfident, plausible falsehoods. And it's that combination, plausibility plus overconfidence, that really, really damages their usefulness and our trust in them.
Exactly. That overconfidence, it just gets you, right? I saw this example that really drove it home for me. Someone asked, a top-tier model for the PhD dissertation title or the birthday of a real academic, Adam Tomian Kalai, and the model didn't just guess wrong once. It confidently gave multiple different incorrect answers for both things across different tries, which shows it wasn't just like unsure, it was actively inventing details confidently.
That's a perfect illustration, and it's something, like you said, many of us have probably run into. You've likely been in that loop, right? You ask the LLM something, it gives you a confident but wrong answer. Then you have to go back and say, no, that's not right, fix it. And then often it apologizes, oh, you're right, and then it gives you the correct information. That whole cycle, it's a direct symptom of this problem we're digging into.
Oh, you do like digging.
And it makes you wonder, well, if it can correct itself, why get it wrong so confidently in the first place?
Yeah, exactly. So given that it can often self-correct if you push it, the natural thought, my first thought anyway, was it must just be bad data, right? I mean, these things are trained on absolutely enormous amounts of internet text. And the internet's full of mistakes, misinformation, half-truths. My initial reaction was, well, garbage in, garbage out. Is that where the researchers started too? Is that the main theory?
It's a very logical place to start, definitely. And look, the training data does contain inaccuracies, no question. There's a lot of noise out there. But, and this is a really fascinating part, the sort of core revelation from the OpenAI paper. Even if the training data were error-free, the objectives I optimized during language model training would lead to errors being generated.
Whoa. Okay, so even with perfect data.
Exactly. Even with perfect data, the way they're trained would still cause them to make stuff up sometimes. This is huge. It means the root problem isn't just the information they learn. It's fundamentally about how they're taught and tested. Specifically, it points to the objectives optimized. That's the key phrase. It basically means what the model is trying to achieve. What counts as success during training.
Okay, hold on. So it's not just the ingredients, it's the recipe, or maybe like the rules of the game you've set up for them. That feels like a really big shift in thinking. Can you break down objectives optimized a bit more for folks maybe less deep in the ML training weeds? What does that mean in practice, and how does it kind of nudge them towards errors?
Sure. Think of objectives optimized as the goalposts or maybe the reward system during training.
Yeah.
It's how I tell the model good job or bad job.
Mm-hmm.
So an objective might be simple, like predict the next word accurately, or in Q&A, it might be produce the right answer. The issue is these objectives often don't really have a way to account for uncertainty.
Right.
They implicitly push the model to always give an answer. It kind of forces a choice, be right or be wrong. There's often no reward or even a possibility for saying, I'm not sure. It becomes very binary.
Right. That makes a ton of sense. And that connects to another really crucial point they make, which is it's way, way harder for a model to actually generate a correct answer from nothing than it is to just look at an answer someone else gave and decide if it's valid or not. They point out there are far more wrong answers than there are right answers for pretty much any question. It's like being asked to write a perfect essay versus just proofreading one for mistakes. One's creation, the other is critique.
Precisely. And doesn't that just resonate with how we work? It's always easier to spot a mistake in someone else's logic or writing than it is to produce something flawless yourself.
Right.
And especially the first time around. And this human parallel is interesting because the sources also note that multiple agents working together typically produce better results.
Like having a checker.
Exactly. Because an agent reviewing the answer of another agent is much better than just having an agent produce one answer in isolation. It's like having an editor or peer review. That validation step is just inherently less complex, less demanding than the initial generation.
That editor idea really lands. It shows these hallucinations aren't just like random noise. They're baked in deep. Like the paper says, and this really stuck with me, hallucinations are baked into the way models are built today. They're not just bugs, they're features of the current optimization process.
Wow, that's pretty profound. It suggests we can't just patch this. It's fundamental to the design as it stands. And this leads us straight to the core mechanism.
Yeah.
How we've been teaching to the test, so to speak.
Mm-hmm.
Think back to school, multiple choice exam. You hit a question you genuinely have no clue. What's the usual advice?
Guess.
Right? Guessing gives you a shot, maybe 25% if there are 4 choices.
Mm-hmm.
Leaving it blank, that's almost always a guaranteed 0.
Ah.
There's usually no extra penalty for guessing wrong compared to just not answering. But there's a definite loss for leaving it blank.
Okay, I see now. So our AI tests, our benchmarks are set up the same way, like a big multiple choice test?
Exactly. The big benchmarks we use to measure AI progress, things like GPQA for reasoning, MMLU for language tasks,
Yeah.
they mostly mirror standardized human exams. They use binary scores, accuracy, pass rate, right or wrong.
Okay.
Models get points for getting it right, and basically 0 for anything else that includes being wrong and includes saying, I don't know.
Yes.
So under that system, what's the smart strategy if you're the AI?
Guess. Always guess.
Bingo. Guessing when unsure maximizes expected score. There's no cost to guessing, only potential upside. So models are, in effect, incentivized to guess confidently rather than admit they don't know.
That is genuinely wild. So the hallucinations aren't just a flaw. They're a learned strategy to get a better score on the tests you give them. The AI is being a smart test taker, maximizing its points, not necessarily being truthful. Wow. It's like we've accidentally trained them to bluff.
It's a brilliant, if slightly unsettling insight, isn't it? And there's more evidence in the OpenAI paper, specifically Figure 2. It shows that base models, these are the models right after that huge initial training phase before fine-tuning, they can actually be pretty well calibrated.
Meaning their confidence level matches their accuracy reasonably well.
Yeah, roughly. If they say they're 70% sure, they're right about 70% of the time. But then comes a key step, reinforcement learning, or RL. And RL often pushes them in the wrong direction.
Right, RL. Can you quickly unpack that? I know it's used to make models more helpful, more aligned with what humans want. How does something aimed at helpfulness end up boosting overconfidence?
Sure. So reinforcement learning basically works through trial and error with rewards and penalties. For LLMs, we use human feedback to reward the model for outputs we like, ones that seem helpful, correct, decisive. The problem is, if that reward system only rewards correct or decisive sounding answers, and doesn't give points or at least a neutral score for saying, I don't know, then the model learns that acting confident, producing an answer, is always better than admitting uncertainty. So RL, which is trying to make the model more helpful, more decisive, can accidentally teach it to sound sure even when it's not. It might end up thinking it's 80% confident, but actually, based on the data, it's only right 45% of the time. It gets rewarded for the performance of confidence.
Wow. So we're essentially training them to be confident bluffers, not systems that truly understand their own limits, like teaching a bad habit a kind of digital swagger. But what about just saying, I don't know? We humans learned that lesson, right? Often the hard way. One of the sources called it the school of hard knocks. In the real world, it looks really bad if you confidently give wrong answers often. But saying, I don't know, or maybe, here's my best guess, but I'm not sure, that's usually accepted, even respected. Models don't have that social credit system, do they? That pressure to be humble.
Exactly right. And that lack of value for uncertainty is starkly clear in the benchmarks. Most of the big ones, GPQA, MMLU, math, sway bench, these tough tests of AI skill, they're still mostly binary graded. They simply give no credit for a model saying, I don't know. None. There's no reward for honesty about limitations. While bench is mentioned as a rare exception, which is good, but it's not the norm.
Which is kind of ironic because OpenAI itself, the authors of this paper, they list humility as a core value. They actually state, it is better to indicate uncertainty or ask for clarification than provide confident information that may be incorrect. But that value hasn't really trickled down into the main ways you test these models. Seems like a disconnect.
It's a significant disconnect, absolutely.
Yeah.
An institutional value that hadn't fully made it into the engineering reality, perhaps until now. And, connecting this to other research, an earlier Anthropic paper talked about models having momentum to give a full and complete answer. They described it as being painful for the model to stop responding, which is a good description of the symptom, right? The model wants to keep talking.
Yeah.
But it didn't quite nail the fundamental cause the way this OpenAI paper does, the flawed evaluation incentives driving that behavior. It's like describing the cough versus diagnosing the infection.
Okay, so if hallucinations are more like a feature driven by our test, not some deep, unavoidable bug,
No.
then they're not inevitable. Is that what the OpenAI paper claims?
That's exactly their assertion. They state pretty clearly that hallucinations are inevitable only for base models.
Right.
Meaning, once you get to fine-tuning, you could theoretically create a model that reliably says, I don't know, when it's below a certain confidence level. And the simple solution they propose sounds almost too simple, but it's all about changing those incentives. They suggest models should basically answer only if I'm above a certain threshold of confidence, say 75% or whatever we choose. If I'm below that, I should just say, I don't know.
That sounds incredibly sensible, practical even. But how do we actually do that? In the evaluations, the benchmarks, what does that change look like?
It means fundamentally changing how we score AI performance. It's a shift in the grading system. First, benchmark creators need to be adding confidence thresholds into their scoring. And crucially, they need to be rewarding abstaining from answering the question if the model doesn't know. So maybe a scoring system like +1 for a correct answer, 0 for I don't know, and -1 a penalty for a wrong answer.
Ah, so you actually penalize the confident wrong guess more than just admitting ignorance.
Exactly. That directly discourages that bluffing strategy, that smart test taker behavior we talked about.
That changes everything. It pushes them towards what the paper calls behavioral calibration,
Okay.
where the confidence they state actually matches their real accuracy. So 50% confident means right half the time. 90% confident means right 9 out of 10 times. Gosh, that would be absolutely transformative for trusting these things.
Totally transformative. And the exciting thing is, this isn't just pie-in-the-sky theory. We're starting to see hints of it. The paper mentions GPT-5 is actually starting to do that already.
Mm-hmm.
And there was that example floating around on Twitter, right? Someone shared GPT-5 apparently responding, I don't know, and I can't reliably find out. Elon Musk commented, called it impressive. And it raises the question for all of us, doesn't it?
Yeah.
Wouldn't you honestly rather see that honest admission, than get a plausible sounding but totally made up answer?
Oh, absolutely, 100%. It builds a completely different kind of trust, a more solid foundation. Even if it means sometimes you don't get an answer right away, it's about getting the right answer, or at least knowing how unsure the answer is, not just getting an answer. Now, the OpenAI paper also tackles some common myths, some widely held ideas about hallucinations, which I found really useful for clearing things up, like the idea that we'll just get rid of hallucinations by making models more accurate overall.
Yes, they address several key misconceptions. On that accuracy point, their finding is critical. Accuracy can never hit 100%. Why? Because some real-world questions just don't have clear answers. The information might not exist, or the question itself might be ambiguous. So just pushing for higher accuracy isn't enough. We need that I don't know capability.
Right. And then there's the belief that hallucinations are just inevitable, baked into the nature of LLMs.
I push back hard on that too. Hallucinations are not inevitable, precisely because models can be trained to abstain when they're uncertain.
Yeah.
It's a choice we make in the training objectives, not some fundamental law of AI physics.
Okay, another one, that avoiding hallucinations means we need bigger, smarter models. That scale alone will solve it.
Yeah, and counterintuitively, they suggest it might actually be easier for a smaller model to know its limits sometimes. Think about it. A model with zero knowledge of, say, quantum physics can confidently say, I know nothing about quantum physics. A huge model with some patchy, maybe incorrect knowledge might struggle more, feel compelled to generate something plausible but wrong. More data doesn't automatically equal better self-awareness.
That's a really interesting point. And they also knock down the idea that hallucinations are just this complete mystery, some weird glitch we don't understand.
Precisely. They're saying, look, we now basically understand the statistical mechanics. We see how they arise and how our current testing rewards them. It's not a magical black box problem anymore.
And finally, the idea that the solution is just to create one really good hallucination test or evaluation.
Right, I argue against that narrow view. It's not about adding one more specialized test. It's about fundamentally reworking all the main evaluation metrics.
Yeah.
We need to build in rewards for expressing uncertainty across the board, making it part of the core scoring for everything.
Okay, so let's try and wrap our heads around this. What's the big takeaway? The real aha moment here, the thing that seems, like you said, super obvious in retrospect, is that these AI hallucinations, they aren't some deep mystical flaw. They're not an unavoidable bug we just have to live with. Instead, they seem to stem largely from the very way you've been training and testing these incredibly powerful tools. You've unintentionally taught them to bluff, to guess confidently to get a better score on your test, just like a student might on a multiple choice exam. You penalize saying, I don't know.
That's the crux of it. And so the path forward isn't some complex new algorithm necessarily. It's a fundamental shift in incentives. It's about rewarding honest uncertainty, maybe giving it a 0 score, while actively penalizing confident mistakes with a negative score. It's not just a small adjustment. It's really rethinking the foundational rewards we've set up in AI development. We need to align their goals with our need for reliable, truthful information, not just plausible sounding sentences.
And that's why this research feels like such a significant breakthrough. It really lays the groundwork for AI systems that aren't just smart, but also, well, honest, trustworthy. Imagine, really picture it, an AI that consistently tells you, I don't actually know that, or, okay, here's an answer, but I'm only 60% confident, instead of just making something up.
Right.
Yeah, maybe sometimes it's a bit frustrating if you wanted a quick, definite answer, but ultimately, that move towards transparency, towards accurate self-assessment, builds a much deeper and far more reliable relationship with these tools. It feels more productive in the long run, and it makes me wonder, if future AI models really do get good at this, at saying, I don't know, or giving us truly reliable confidence scores, how will that change what we expect from them day to day? Could it shift not only our trust, but also the kinds of tasks we hand over, and how we as humans adapt to working with information that comes with its own uncertainty built in? What would that mean for how we learn, how we research, and how we make decisions with AI in the mix? Plenty to think about there. Thanks for joining us for this exploration, and until next time, this has been The Deep Dive.
Hope you enjoyed listening to my voice. If this was useful, hit subscribe and share it with a friend. And there's a little extra for you in the show notes or description.